Okay, hi everyone. This is Professor Sebastian. We are moving into our Chapter 5 notes, in statistics. And our Chapter 5 statistics class notes are about modeling variation with probability. Okay, and what do we mean by that? Well, first of all, these words won't totally make sense yet, but our two main objectives are to understand empirical and theoretical probability models and to apply some basic probability rules. But before we actually get into these types of models and the basic probability rules, I want you to understand what is randomness. So that's what section 5.1 is about. What is this idea of randomness? So we're going to use technology here to simulate randomness, and I won't expect you to repeat this, and you won't have to do any homework, so I won't show you exactly how I did it, but I just want you to understand what I'm doing when I'm simulating randomness. And then I'm going to talk about what's the difference between empirical and theoretical probabilities in this section. Okay, so what is randomness? First of all, the word random means having no predictable pattern. Okay, now that doesn't mean there isn't a pattern. Oftentimes we see randomness will display a pattern. You can imagine rolling a die and then, is it possible to roll 3 ones in a row? Of course it is. You're not going to roll a 1, a 2, a 3, a 4, a 5, a 6, and then again a 1, a 2. So there are going to be kind of patterns, and if you look for them, you can actually see patterns. It's just that we could never predict what the pattern is if something's truly random. People themselves are not good at identifying truly random samples or random experiments. So most of the time we use technology, and for us that's going to be StatCrunch or some other randomizing device. Excel has random number generators built in. Many of the different pieces of software do as well, such as a random number table even. There's books that have random number tables used to simulate randomness. Of course, any piece of software or table that actually is trying to simulate randomness, it's not truly random because it starts somewhere and somebody has developed a code that if it starts with a certain value, it will give a next number which looks random, but it's not truly random. We're just trying to simulate it. Okay, so for example, let's simulate randomness here using StatCrunch. I'm going to generate a random number table to simulate 20 coin tosses. So, you flip a coin, flip a quarter, you're going to get a heads or a tails. What I'm going to do is I'm instructing StatCrunch to generate sequences of 20 integers, all between 1 and 10. Sequence just means a list. A list of 20 integers, all between 1 and 10. And I'm going to make the odd numbers be the heads. So in other words, a 1, a 3, a 5, a 7, or a 9 will indicate that a head was thrown with that quarter. And the even numbers will be the tails. So a 2, a 4, a 6, an 8. Or a 10 will be the even numbers that represent. So it's about a 50-50 chance, right? You get about a 50% chance, 50-50 chance of throwing a head or a quarter if you flip a coin. That's why we use it to start athletic events, etc. Okay, you don't need to do this. If you want to read this and see how you do it, you can actually play with it and generate these sequences yourself, but I'm not going to require that. So I did it once, and I just wrote down the numbers here. So I had StatCrunch generate a list of random numbers. So these are to be thought of as random numbers. It went 6, 1, 6, 1, 10, 1, etc. And since we're letting odd numbers be the heads and even numbers be the tails, I'm going to imagine that I flipped a coin 20 times, and this was the result I got. So I got a tails for this 6. This 1 meant I got a head. This 6 meant I got another tails. This 1 meant I got a head. This 10, tails. This 1, heads. This 7, heads. This 10, tails. This 5, heads. This 3, heads. This 6, tails. This 5, heads. This 2, tails. This 5, heads. This 9, another head. This 9, another head. This 9, another head. 1. I'm sorry. Anyway, the 5991, that's the 5991, those 4 heads. Then a 2 was a tails, then a 3 was another head, then a 3 was another head. So the longest streak we saw, and hopefully you recognize as we were talking about it, were these 4 heads that we got in a row. Now, if I started off with a coin, I got 4 heads in a row, you might think, hey, that's not a very fair coin. So anyways, just understand that even though we have randomness, and at first it looks like, hey, tails, heads, you're going to get every other one. But then, no, here we got 2 heads in a row. Another spot where we got 2 heads in a row. Here we got 4 tails in a row and 2 heads. We never got a spot where there were more than 1 tail in a row, but that's okay. You never know what you're going to get on any flip of a coin. But I did see a streak here of 4 heads in a row.